Dear students, today's topic is finding velocity time graph and acceleration time graph from the position time graphs under the topic kinematics, which means the study of motion of objects. Let us take a few examples. Now, you can see here in this graph, this is a graph connecting displacement or distance on the y-axis and time on the x-axis. The slope of this graph or the gradient of this graph represents speed or velocity. Now, if you look at the gradient, the gradient is constant. Now, since the gradient is constant, it means the velocity is constant or uniform. Now, we know that whenever there is a uniform speed or uniform velocity, the acceleration is 0. Now, to confirm it, you can see that the uniform velocity is a graph which is parallel to the time axis. Now, what is the slope of any line which is parallel to the x-axis? The slope is 0. So, the physical quantity that represents the slope also becomes 0, which means acceleration is 0. I hope this concept is clear. Look at the next situation. Here we have again displacement time graph and velocity time, corresponding velocity time and acceleration time graph. You can look at this one. The graph is decreasing, which means it has a negative slope. What does a negative slope for displacement time graph mean? A negative slope in displacement time graph means negative velocity. But is it varying or constant? The velocity is constant. So you can see that the graph representing velocity time graph is a constant, or it is a horizontal line which is parallel to the x-axis. Now, what is the slope of a parallel line which is parallel to the x-axis? It is 0. So, though the velocity is negative, here the acceleration is again 0. I hope this example is clear. Now, let us take a third case, third situation. Here, the displacement time graph, you can see that it is not a uniform graph. It is, the slope is increasing. The slope is not constant. The slope is increasing. You can see if the graph is going towards the right, the slope is positive. Also, it is going closer to the y-axis. You can see that the angle is continuously increasing, which means the slope is increasing. The slope is positive, which means the slope is increasing. So you have a positive velocity. Now, if you draw the velocity time graph, you get a velocity which is changing at a uniform rate, because the velocity is positive since the slope is increasing. Now, the positive slope here represents positive acceleration. Since the velocity is increasing at a constant rate, acceleration is constant. Now, we will look into another example. Again, look at the situation here. This is again a displacement time graph. Here we have the displacement time graph Then we have the velocity time graph and the corresponding acceleration time graph. In this velocity time graph, we can see that the slope is decreasing. But the slope is decreasing, but still it is positive. So the velocity is positive, but velocity is decreasing. That's the difference. Though the slope is decreasing, it is positive. It is in the positive quadrant, or it is towards the right. Now here the velocity is decreasing. Now the slope of the velocity time graph is negative. It is moving to the left. The slope of the velocity time graph is negative, which is showing us that the acceleration is negative. So here, but still the acceleration is constant. So you have a constant negative acceleration. Now, look at another situation here. The curve is going down, which means the slope is becoming more and more negative. So the velocity is negative. In this case, the velocity is negative. Now, but the slope is becoming more negative, so the velocity is increasing in the negative direction. Now, since the slope of the velocity time graph is negative, we have negative acceleration, but the velocity is changing at a uniform rate, so again the acceleration is uniform. It is constant. Look at this situation now. Here again the displacement time graph. The slope is increasing, but still the velocity is negative but increasing. Here you can see that the velocity is negative, the slope is increasing, the velocity is negative, but see, the velocity is negative, but it has a positive slope. The velocity time graph shows a positive slope, which means the acceleration is positive. But the acceleration is again constant, uniform acceleration. You have to deal with different situations where the variations happens in position time graph and corresponding variations in velocity and acceleration time graphs happens. Should be very clear for analyzing any type of graph. If you look at the graph of an object which is thrown up with a velocity and it reaches the maximum height and falls down. See, if you take acceleration due to gravity as 10 meter per second square, you can see that this is a distance time graph or displacement time graph. See here, it is displacement and time in seconds, displacement in meter. This is displacement time graph. You have the corresponding velocity time graph, that is velocity in meter per second and time in seconds. Okay, so here we can see that the displacement time graph, the displacement is increasing. See here, and then the direction is changing because the object is going up, reaching the maximum height, and it falls down. Now what happens to the velocity? See here, the velocity is, the distance is, there is a variation in the displacement And correspondingly, you can, if you calculate the velocity, you can see that the velocity is decreasing at a constant rate. At the maximum height, it becomes zero. At the maximum height, when it reaches the maximum height, the velocity becomes zero, and then when it falls down, the velocity increases. And the final velocity just before touching the ground will be the same velocity with which it was thrown up. So there are so many things that you have to consider here. The acceleration due to gravity is constant, which is a value ranging from 9.78 meter per second square to 9.81 meter per second square, but for convenience we consider it as 10 meter per second square. So in this graph you can see that the velocity is decreasing, becoming zero, and then increasing for an object thrown up with a particular velocity. Here, let us look at the acceleration of that. Throughout the journey, the acceleration due to gravity is taken as negative, constant value. Now, by convention, we have taken the downward direction as negative. So, since the downward direction is negative, it is convention, like how we are applying it for a vector. We assign the direction. When an object is thrown upwards vertically with a velocity, initial velocity Vi, its velocity decreases by 9.8 meter per second in every second. At the maximum height, which is calculated by Vi square by 2g, final velocity is 0. The time taken to reach the maximum height is called the time of ascent, which is calculated as Vi upon g. On reaching the maximum height, the object is momentarily at rest. After that, it starts falling down like a freely falling body. The velocity increases by 9.8 meter per second in every second during its downward motion. The time taken by the body to reach the ground from the maximum height is called time of ascent. Now, on reaching ground, just before touching the ground, it attains the same velocity with which it was thrown up, and you can calculate the velocity. So, this is the situation for an object which is thrown up, reaching maximum height and falling down. So, if it is just a freely falling object, what is meant by a freely falling object? A freely falling object is something that is completely moving under gravity. There are no other forces, even the other air resistance or other drag forces are ignored. Here you can see that the velocity downward direction is taken as negative. So the velocity time graph is drawn in this way, showing that. Now the downward direction is taken as negative conventionally. So because of which the acceleration is constant, and the acceleration is constant, and you can see that it is negative, minus 9.8 meter per second square. Now for this case, what is the distance displacement time graph? You know, in the previous case you have seen that for the part of this journey, that is from a height coming to the ground, which means freely falling object from a particular height falling to the ground, the graph of displacement time graph looks like this. This is displacement, which is in meter, and this is time, which is in seconds. We have yet another case here, which is of bouncing ball. Now, the displacement time graph for the bouncing ball, you can see here, it is continuously changing its direction. As it comes down, we are throwing the ball from a height, it reaches the ground and it bounces back. Again reaches the height, maximum height, then again falls back, and then again it bounces. So whenever it touches the floor, it bounces back. Now here we have taken a case of elastic situation, that is where we assume that energy is not lost. It is not possible in real situation. In real situation, this height can change because energy will be continuously wasted in the form of friction, heat, sound, etc. So, but here we are taking an ideal situation where the object's the height is not decreasing. Now we can see the velocity time graph in this particular case. See, when it is falling, here velocity is taken as negative. Now the moment it touches the floor, its direction is continuous, that instantly changing. So the instant change in the direction gives a sharp peak in the acceleration. So for this part, the acceleration is constant. You can see here acceleration is negative and is constant. But for this part, for the bounce part, there is a sharp peak in the acceleration which shows that there is a sharp change in the velocity. Again, here it is the rising part reaching the peak, and then it is again falling down, touching the floor, bouncing. Now again we have a sharp peak in the acceleration. But for the rest of the journey, it is constant negative acceleration. The moment it bounces, you can see that the acceleration is sharp. And there is a very great change. It shows the change in direction. Okay. So, this is again the case of a bouncing ball. Let us take another example. That is when a ball is rolling across the horizontal surface and then down the incline. See, here this is the horizontal surface. Here it is showing that there is friction. So obviously energy will be wasted. Some of the energy will be wasted. So the ball is rolling on the horizontal surface and then it is moving down. So the velocity time graph for this, it is, it is decreasing because there is a friction for the surface. And after that, when it is coming down, there is a sharp increase in the velocity. So the velocity time graph for this looks like this. Now, what about this? If the ball is moving on a horizontal surface, it's going along a ramp and then again rolling along a horizontal surface. How do you represent the displacement time graph, velocity time graph and acceleration time graph for this? This is the displacement time graph. This is the velocity time graph and this is the acceleration time graph. Now here you can see that the distances, it is changing uniformly. After that, here the slope is constant, but then again there is a decrease in slope. The graph looks like this. This is for the section 1. This is for section 1 and this is for section 2 and this is for section 3 of the ramp. Correspondingly, for this part, for the first part, you have the velocity constant. But in the second part, you can see that the slope is decreasing. Though it is positive, it is decreasing. So the second part, the velocity is decreasing. And again, for the third part, the velocity is becoming constant. So this is for the third part. How does the acceleration time graph look for this? For this part, the acceleration is 0. So you can see that the acceleration is 0 here. Now, for the second part, the acceleration is negative, and for the third again the acceleration is 0. So dear students, I hope you have understood the various situations under which you can compare displacement time graphs, velocity time graphs and acceleration time graphs. Thank you. We will have a more detailed explanation of different types of graphs under different situations in our next lesson. Thank you.